So our next speaker, I'm super excited to announce. He's a professor of physics at Stanford. He's a quantum field theorist and also condensed matter theorist known for his work on topological insulators, quantum spin Hall effect, spintronics, quantum Hall effect, and high-temperature superconductivity. He's one of the most honored and respected condensed matter physicists of his generation. It's my honor to introduce Zhang Shoucheng.
So which clicker do I use? Either one, okay. And this is on? Yes. Thank you for this great opportunity for me to come and to speak to you here. Since we're gathering here to look into the future of one of the greatest innovations, I think, of humanity, namely the blockchain, I therefore like to invite you as you try to predict the future of this very exciting development and invite you to a journey into the past, basically looking at the similarities. So as you heard from the introduction, I'm both a physicist. I'm also an investor, particularly in this field of blockchain, and we started doing that 4 years ago. And I like to explore these similarities. It may appear to you these two things are totally distinct, but actually I see a lot of commonalities. Actually, I like to make the argument in order to see the future of this field, we actually should look into the natural world. What are the mechanisms that the natural world uses as medium of exchange? The words that we hear a lot in this field are the mediums of exchange. How do you place a value on the medium of exchange? And what is the value of the consensus itself? So therefore, the title of my talk is In Math We Trust. I try to develop some kind of fundamental thinking and the foundation for crypto-economic science. I think this is really a very exciting opportunity. Economic science has always been viewed as a not so precise science, but I think as the world moves into crypto-economics, it will become a very precise science, and it can only become so as we make some analogies with natural sciences in this field. So let me take you on a journey and tell you a story about one of the greatest scientific revolutions of the entire natural science field. And namely, this is the concept of a medium. In the beginning, people talk about, let's say, if I have two electrical charges, they can interact. Even though they're not touching each other, they can interact at a distance. And this is a pairwise interaction at a distance. But later, people feel this concept is not so natural. Why can two particles interact with each other even though they're very far separated away from each other? So then they introduce a new idea called the electrical field. They say the way they interact is one particle generates an electric field, and that electrical field in turn acts on the other particle. So this was an interesting concept, but it was introduced as a kind of an auxiliary concept that makes the description more natural. So when you look at the analogy, this analogy is almost perfect to the difference between the barter economy and the monetary economy as a medium of exchange. In the barter economy, you do this pairwise exchange of goods, but later we use a medium of exchange so that you exchange goods to money and money back into the gold. But then the question comes, what is the intrinsic value of the medium of exchange, whether it has its own intrinsic physical identity or does it have a value of its own? So of course, today we're still debating as we try to understand this very new concept of blockchain and medium of exchange. But so there was a revolution in the field of physics, because in the beginning, the idea of the field was introduced as an auxiliary concept. But later, people realized the field has its own identity. It's actually a propagating electromagnetic wave. But what is the value of this medium of exchange? And that was actually the Nobel Prize-winning work of Albert Einstein. Albert Einstein actually did not win Nobel Prize for special theory of relativity. He did not win Nobel Prize for the general theory of relativity. He won Nobel Prize for what is called the photoelectric effect. But to be more precise, he gave a precise value for the medium of exchange. In the physical world, the value is measured by energy. So he told us precisely a formula that the medium of exchange has a precise value. So today in our world, as a medium of exchange, let's say in economic world, what is the value of medium of exchange? So we would like to argue that the value of the medium of exchange is actually its consensus. Let's imagine we can use one commodity as a medium of exchange, such as apple, or we can use gold as a possible medium of exchange. Let's actually, for the sake of argument, say gold has no commodity value, but apple actually has some commodity value. We can actually consume it. But why was gold eventually adopted into a medium of exchange, even though it has little kind of consumable or commodity value of its own? That's because the idea or behind the idea of one apple, there's a very, very broad understanding about one apple. There's some good apple, there's some not so good apple, and different people assess one apple in different way. But 1 ounce of gold, everybody can agree. Why can everybody agree? This is, again, the contribution of two great physicists. One, you may know the story of Archimedes. The king gave him a task that some handyman fashioned him a crown. He has some doubt whether the crown is made of real gold or not, and he gave this task to Archimedes to assess whether the crown is made out of true gold or is some fake alloy with some other base metals. And this was a very, very difficult problem because you have to solve this problem without breaking the crown. And one day, Archimedes was so frustrated, he has to take a bath. And as he was floating in the bathtub, he suddenly had a eureka moment. And basically, if you have a crown and the same weight of gold in air, they may weigh the same. But when you put them into water, they will actually be different because the crown, if it includes other base metal, will displace more water volume and therefore a more floating force from water. So this gives you a very precise way to measure whether gold is really gold or not. Also, Isaac Newton, you may know he is a great physicist, but he actually made a great contribution in adopting gold into a monetary standard. He was actually the master of the royal mint. And at that time, people already fashioned gold coins, but one gold coin, people may not have consensus because some people try to rub it a little bit and to collect an extra gold. And if you do enough times, you get an extra gold coin. In order to prevent that, Newton actually invented a method that at the edge of the coin, he put in these stripes, so that if somebody attempts to rub it, it will immediately be detected. So therefore, this is the concept that for gold, one gold coin or 1 ounce of gold, we understand precisely what it is. But for one apple, we don't understand precisely. There's no consensus. But consensus itself has tremendous value. Why does consensus itself has tremendous value? In physical world, we see two types of phenomena. On the extreme right, you see a disordered phenomena, and in the middle, you see an ordered phenomena. Namely, if you put some magnet onto your refrigerator, what is really happening inside this magnet is that all materials are made out of electrons, but electrons are little compasses, and they have a magnetic direction. But in most cases, the material is not magnetic because this compass cannot reach consensus. They point in some random directions, so they don't act magnetic. But at some low temperature, if they can take away entropy and give it somewhere else, all the compasses can align themselves, and they reach a consensus state. They decide with consensus in which direction to point to. And that phenomena has value of its own, because in the natural world, there's a second law of thermodynamics. It says the entropy always tends to increase. By reaching consensus, you are lowering the entropy, and so therefore it has to dump the entropy somewhere else. When you really think about it, life is about these phenomena. Life is about reducing entropy of our own. We become more ordered, we become more organized, and by dumping entropy somewhere else. So therefore, reaching a consensus can be measured by entropy, and itself has tremendous value, almost as valuable as life itself. So just as I argued that in the natural world, there are these phenomena where they can spontaneously and self-organized fashion reach a consensus state. And so this, I gave an example for the natural physical world of this ordered magnetic state where the electron spins, the little compasses reach a consensus and decide all to point in one direction. There's no central master which is telling the electrons which direction to point to. The consensus is reached in a distributed fashion in a self-organized organized fashion. There's also spontaneous consensus in biological world. If I have a lot of bacteria, the bacteria can all emit some receptors, and they can receive the receptors emitted by other bacteria. So once the bacteria receive enough receptors from other bacteria, he will know that there are enough neighbors around, and then they can collectively decide to do something, for example, light up. And there's indeed a class of bacteria which does exactly that. And this mechanism is called quorum sensing. Now you see these words are even very similar. We talk about medium of exchange, we talk about consensus in the natural world, and quorum is the central concept of the Byzantine fault-tolerant protocol. So I'm just giving examples that true distributed consensus is possible, even in the natural world. But it is only possible by reducing entropy of itself, but it has to dump entropy somewhere else. And this is a famous result in computer science. So you may think, why in a very random and distributed world we cannot have some master algorithm which deterministically help the system to reach consensus? And there's a theory in computer science, one of the most beautiful theorem, I think, in computer science, called the Fisher-Lynch-Patterson theorem. And that basically states that this is not possible. So we have an analog of that in the physical world. So to reach consensus without any extra cost is like reducing entropy, and that violates the second law of thermodynamics. And actually, one great physicist, Maxwell, thought about whether some higher intelligence can do that. He called this Maxwell's demon, something that can reduce entropy without the cost. So the statement by Fisher-Lynch-Patterson theorem to say such master deterministic consensus algorithm in a distributed system is not possible is similar to the statement of second law of thermodynamics. So therefore, this blockchain, the very first version of the blockchain, is very consistent with this general idea that by reaching consensus, that the blockchain block all uniformly vote for one block, but so that reaches a very low entropy state, but it has dumped entropy somewhere else by the proof of work. So this really gives rise to a great revolution in the networking world. The networking world, the history of the networking world, can be summarized by a periodic oscillation of centralization and decentralization. In the days of the circuit switching protocol, the most efficient way to operate such a network will be some centralized monopoly. So that will be then AT&T, and it becomes the kind of the central monopolistic power in the circuit switching era. But then with every time a decentralized protocol gets invented, for example, TCP/IP is at the lowest level a decentralized networking protocol, and that immediately broke the central monopoly of AT&T, and that enabled the whole internet era. But then the content gets very, very fragmented. So then central platforms start to emerge, which would organize this content. They don't generate content themselves, but they're organizing these contents. And these are the likes of Google and Facebook and so on and so forth. So this led to another centralization. So the decentralization from circuit switching to packet switching gave rise to TCP/IP, but then the task of organizing the content fall on into some giants become a centralized monopoly. So what we're seeing right now, the blockchain world, is again a decentralization trend that fundamentally enabled peer-to-peer, not only peer-to-peer communication, but peer-to-peer trust building and consensus. And this will really enable a new type of economy which was not possible before. And as Hongfei just started also talking about, obviously we're going to see next wave of centralization and decentralization. And that's because once all the tokens are there, centralized exchanges will start to organize themselves into centralized exchanges, but maybe the next wave it will be the decentralized exchange. So this is the history of the world, but also reflected upon us in the history of the networking world. So we're really in a very, very exciting era in human development, because when we think about among all human knowledges, which branch of human knowledge we have most consensus about. In a lot of social science disciplines, there's a lot of argument. People cannot reach consensus. These sciences are not what we call precise science. But in the world of mathematics, I would say among all human knowledges, we have the most consensus about one branch of knowledge, which is mathematics. The Pythagorean theorem, a squared plus b squared equals to c squared, no one can argue. And if I have a mathematical cube, it's a perfect mathematical cube. If I make a physical cube, we have some disputes whether it's precisely a cube. But the mathematical cube is precisely a cube. But at the most fundamental level of the natural world, the deepest knowledge, the deepest truth about our natural world is expressed in the language of mathematics, like Einstein's equation. And this is the equation of what is called the standard model. It describes the natural world at its most fundamental level. But surprisingly and beautifully, at the most fundamental level, the deepest truth and the deepest secret about nature is expressed in terms of mathematics. So what a wonderful era humanity could enter if our trust and our consensus is built upon a branch of human knowledge that we have the most consensus about. And this world and this future I call in math we trust, because in a very precise sense, as we have seen, that the natural secret is revealed to us through the language of mathematics, and in that sense, mathematics is also the language of God. So in math we trust. What are the important mathematical primitives? So we already talked about public key and private key encryption based on elliptical curves, cryptographic hash functions, which is the basis of proof of work. Zero knowledge proof, I think, will be one branch of mathematics which becomes tremendously useful. And this is the era of going the content. So far, all user-generated content went into centralized platforms, a very important trend. It should go back to the users and owned by users, but zero knowledge proof can kind of protect those privacy content, but selectively give out certain informations. And this will be really truly enable a data marketplace which ontology envisions. And also secure multi-party computation, differential privacy, that we can actually add noise to individual data so that they don't become individually identifiable, but they become useful in the statistical sense because this noise will be canceling out. Formal verification is something I find tremendously useful, that in smart contracts, sometimes they are written by humans. They may not exactly do what the humans intend to do, but the mathematics of formal verification on blockchain can help us to identify those. Homomorphic encryption, I think, will be very, very big. Maybe make smart contracts more private. But also, there will be debate, and the blockchain is only one possible consensus mechanism. Maybe it's more natural to use a DAG, the directed acyclic graph. So the future of this field, I think another very exciting trend is to combine AI with blockchain. Right now, I think AI is broken. It is broken because the data are centrally monopolized. And anytime any resources are centrally monopolized, it may stop innovation and development of new algorithms. But the availability of the blockchain enables a new marketplace. And that marketplace will have the right incentive through token economy to those who contribute to the data. And finally, that contribution to the data may make AI finally possible. But I think the most exciting prospect, and that's what we collectively, as we gather here, have to think about is how the crypto economics can help to make the world better, how it can do social good. And because AI needs data, and in a data marketplace, the corner cases are the most important. When we want to improve AI accuracy from 90% to 99% to 99.9%, those improvements will not be made by yet another type of typical data, but by the corner cases. So therefore, in a fair data marketplace, the value of data will be measured by mutual entropy. This is the idea that if the new set of data is very, very different, such as representing corner cases, that will improve AI to improve the most. Therefore, in such a data marketplace, those kind of corner cases data become more important. But in the real social world, the minorities will have this very atypical data behavior. So and then a fair data marketplace will value their data the most. And then finally, we can turn an ugly duckling into a beautiful swan. The ugly duckling is not ugly but simply because it's different. But difference, it will be valued the most. So that will actually promote a minority finally through crypto economic world and therefore in the natural world. So AI and blockchain can really exist in natural symbiosis. We really have to think about blockchain compliance. There may be, with the rush of ICOs and so on, there will be a lot of kind of negative behavior, which AI can possibly enforce some automated consensus into the blockchain world. So I think we are really in an exciting era in human development. Humanity really, the GDP, worldwide GDP was basically staying flat for 1,000 years until scientific revolution happened. Scientific revolution happened because Newton's book, Principia, mathematical principle of natural philosophy. And after that, we understand the natural world through the most natural language of the natural world, which is mathematics. But society, so far, still is not described by a very precise science. Economic science is not very precise. But so far, but now we really enter into a new world. The socio-economic behavior are all based on a trust, which is based on math. And then we can finally maybe use mathematical principles to understand at least first the crypto-economic scientific behavior and maybe to understand economic behavior at all. So this is really maybe if you look at the scientific revolution as one of the greatest moments in human history, we're maybe entering another new great moment where this mathematical language becomes the fabric of the crypto-economic world. Thank you.